Hello class, let's discuss this problem that we tried to solve in class, right? This one right here, create two different functions f and g such that three different things. All of these letters are independent from the others. And I want to begin with b because it's the simplest. This should have, in my opinion, this should have been the first letter. But anyways, so let's address this one. Let's create functions f and g such that the composition of f with g is not the same as the composition of g with f. Once again, you need to understand what this means. Function composition. If you understand the concept, right, the overarching or arcing, I don't remember the word. If you understand the idea, the concept, it is simpler to address difficult problems like this, right? So remember, when you have two functions, in this case, I'm putting g and f in this order, and then later f and g. So what is this? When we do this thing, when we write the symbol, what does this mean? F of g of x. What that means is the following, guys. It means that you give an input x to the function g, it makes its processing, and it gives you its output known as g of x, right? And then this output of g is given as an input to f, and therefore f gives you this, right? Which is the output given this input, f of g of x, right? So that's what we understand by function composition. Basically, the application of two functions in succession, one after the other. Well, in this case, this is the second one. And in this case, we first apply f to any given number. I first apply f, which gives me its output. And to this result, I give this result to g, which processes it and gives me its output, which is g of f of x. Now, if you think about these two things, guys, this final result and this final result, this is what most of the times will happen. What I mean is this: the thing that is most likely to happen is indeed this thing, that the results of this ordering first apply g and then apply f. This is the result, which is here, will be different than the opposite order. First applying f and then applying g, having this result at the end, and it's the same, right? Same as this. The most likely thing to happen, guys, for functions in general is that this result and this result will be different. Okay, because it's very hard to conceive functions in which the order in which you apply them doesn't matter. If you look at real life, the way in which you do things actually matters a lot. Let's talk about taking a shower and getting dressed, right? It's two different things. What is the first thing you do first? You first get showered, you first take a shower, and then you dress. And the end result is you with clothes and shiny and ready to go, ready to work, right? And if you do the opposite thing, if you first get dressed and then you take the shower, what's gonna be the result of this? I mean, yeah, you're gonna be dressed, but you're gonna be all wet and soaking, right, with water. So this is not the right order. The order in which you apply functions does matter in most of the cases. This is the trivial or the common thing to happen. And therefore, any almost any function that you can create will have this property, right? If you think of this, f of x equals, let me create something very simple. F of x equals x plus 1 and g of x equals 2x minus 3. Well, let me complicate matters a little bit more. 3x minus 1 and g of x equals this. If we first calculate this, the composition of f with g, we're going to have the following, right? And if you simplify this a little bit, you get 6x minus 9 minus 1, which is 6x minus 10. So that is f of g of x. And on the other hand, if you work with the same functions, but you apply f first and then g, then that would be doing g of f of x. That is, you first calculate f of x, and then you give that input to g. What is f of x is this, and you give this input to g, and you're going to be having this 2 times 3x minus 1 minus 3. So you get 6x minus 2 minus 3, so you get 6x minus 5. So clearly, this and this are different, and therefore for these two functions in particular, this one holds. And that's going to happen with most functions. Any two functions you can create at random will fulfill this thing. The composition of the first with the second is going to be different from the composition of the second with the first. Okay, so that's B. Now let me make a pause, and so we can do A, which is the cool one, yeah, right? The interesting one. This is actually way too trivial. Okay, so now the letter A, this one right here, this is the very interesting problem. This is not trivial. You need two functions, f and g, such that the composition of f with g is the same as the composition of g with f. And once again, you need to understand what composition is. It's basically the application of one function after the other. Okay, like I just explained in the previous letter. Okay, guys, so basically, if you notice in here, we can achieve this thing like we can achieve basically the process of, sorry guys about that interruption. So I was telling you, okay, we need two functions, two machines that no matter in what order I place them, whether the first one and then the second one, or vice versa, we get the same end result in here. We're gonna get the same end result. Okay, if you get to think a little about this, guys, this is achieved as long as G and F are doing opposite things, opposite actions, or opposite uh, behaviors of or processes. Behaviors. Why? Very simple. Consider just a very quick example. G is a machine that adds 1. F is a machine that subtracts 1. Right? Okay. So basically, you're gonna put any number inside, any number x inside here, and G will give you this output, right? Because that's what G does. It's gonna add 1, and then this number you're gonna put inside F, and since F is the machine that subtracts 1, what are you gonna be ending up with? X, because if you subtract 1 from this, you're gonna get X. So basically, you start with some number and you end up with the same number, because you change this number by doing some process, and then you reverse that process, ending up with the same thing with which you started, right? And it's gonna happen the same if you act in vice versa. First F, which is the function that subtracts 1, and then G, which is the function that adds 1. So obviously the same is gonna happen. Input X, outputs X minus 1. Put this into G, G will add 1, and therefore what are you going to get in the end? You're going to get X. You see? You see? So basically, what are we doing here? In all of this row, we are calculating F of G of X, all of this, and that's going to be equal to X. You see? And in all of these, guys, by first applying F and then G, we are calculating g of f of x, and as you can see, you're getting x in the final result. So in both cases, f of g of x is x, and g of f of x is also x. What does this mean? What is the conclusion? The conclusion is that f of g of x is equal to g of f of x, which is what you have in here, right? The composition of the functions doesn't matter. It's going to be the same as long as those two functions behave uh, in an opposite fashion, in an opposite way. In other words, they are inverse functions, one to the other, right? So that's it, guys. We have basically created two functions. I said g of x equals this one, and f of x equals the opposite, right? And for these two functions, this will hold. This will be satisfied. And any other two functions that are similar like this, that are inverse functions. For example, g of x equals to x, which is a function that multiplies by 2, and f of x is x over 2, being the function that divides over 2. These two functions, if you first calculate the composition of f with g, and then g with f, you're going to find that both compositions are the same, right? And any other type, it doesn't matter. I don't care what type of inverse functions, as long as they are doing the opposite, they will satisfy this property. And finally, create the functions such that f of 2 equals g of 2. This is in fact, once again, very simple. All you have to do is create one function at random. I'm gonna do something very simple, 2x minus 1. Okay, I'm coming up with this completely at random. Okay, this is completely out of the blue. And then evaluate this function in 2. What do you get? You get 3. So f of 2 is equal to 3. Now all you have to do is create a function g such that g of 2 is equal to f of 2, which is 3, according to what we did in here. Okay, you need a function g such that evaluated in 2 is equal to 3. And guys, it's easier to create this function than than to not create it. All you need to do is this, like start by doing something like this: g of x equals g of x equals, let's say, any number 5x, okay? And then leave, suppose we want to add a constant here that we don't know yet. Okay, we need to add a constant which is still not known. Okay, and if you want this function to have this property, if you want this function to have this output of 3 when you evaluate it in 2, then what you're telling me is that when you evaluate in 2, which is equal to 5 times 2 plus c, right? This has to be equal to 3, right? G of 2 must be equal to 3, and so 5 times 2 plus c must be equal to 3, and therefore plus times c must be equal to 3, and therefore c should be minus 7, right? Am I right? Yeah, that's right. And that's it. You have found c, the constant that you at this point was unknown, right? And then you just plug it in there and you're done. Okay, after you do that, g of x equals 5x minus 7. That's it. This function, basically I created this function, or I built this function to have this specific property by leaving this constant unknown for a short period of time. Okay, you see, I put this number completely at random. It could have been a 3 or any other number you wanted, besides 2, because that's the one I have in here. And then I tailored to my own desires this function, right? And now, as you can see, this function, when you evaluate in 2, is going to be equal to 3. And this function, when you evaluate in 2, you're going to get also 3. And that's it, right? That's it. We're done. This is one of the functions. This is, where is it? Okay, this is the other function. And both have this property that their evaluation in 2 is the same. Try to take this approach, the one that I just explained, and create 2 other functions in this way. Not this. Do not copy these ones. Create 2 on your own by following this approach. Okay, I tailored this function g to have some properties that I wanted. I know it can be kind of tricky. Repeat the explanation as many times as you need so you can understand what I did. And if you didn't, tell me again. And besides, I'm gonna be explaining this again maybe when I solve this when I record the solutions to the problems from the survey. So that's it, guys. Thanks so much. Take care.